Welcome to the first video from Chapter 2, Section 4. The entire section is about finding real zeros, but we're going to start off with a review of division. So if you went back to first grade, or maybe not first grade, but somewhere in elementary school, and I asked you to divide 156 by 9, it would have been a tough question then, would have been quite a process. Right now, hopefully it's going to be more review. So we would take 156, get a pen there. We'd say divide by 9, so I'm kind of doing the really old way of doing this. But I'd ask myself, how many times does 9 go into 1? I would say 0. So I move over one space and I ask myself, how many times does 9 go into 15? I put a little 1 right there. It goes in one time. Then you might go 1 times 9 is 9. And you're going to subtract that 9 from 15. We get a 6. Okay, at that point we would take the other 6 that's here and just kind of drop that down. Get 66. Now I ask myself, how many times does 9 go into 66? And the answer for that would be 7. 7 times 9 is 63. We subtract that, we get an answer of 3. And at that point we'd be done. We've used all of the numbers in the original, in the 156, and so we need to stop. And so part of our directions for this question are to label the different parts, and then we're going to combine all these parts to kind of see how they go together. I know it seems kind of like an oddball question right now, but there's a purpose for this. When we look at the example with polynomials, we're basically doing the same thing, just with lots of variables. So if we had to label all of this stuff, I'll do that in blue maybe. 156 would, I'm just going to call the original. I'm not sure if there's probably a better word for it. I'm just not thinking about it right now. Okay, that's the original. The divisor is 9. The quotient is 17. So the answer to the division problem. And then 3 would be the remainder. So we've kind of labeled everything, but at this point, if I was wanting to kind of show how everything went back together, a couple ways I could do that. The first thing I could do is say, I took 156, I divided it by 9, my answer for that was 17, but I still have this 3 that's left over, and that 3 still needs to be divided by that 9. So really in the end I get maybe 17 1/3 as my answer. And then another, we're going to call this the fraction form because there's so many fractions in it. Another way of thinking about it is that if I wanted to get back to the original 156, I would have to go 9 times 17 plus the 3. Does that make sense? If you look back at the original, I'm basically saying, let me get my pointer here, that 9 and 17, that's kind of what I did in this process to undo the 156, and I still had a 3 left over. So 9 times 17 plus 3. In the end, when we look at our second example, we're going to call this polynomial form. So just a little quick review of how we used to do division. Now we use our calculators a lot, or we think through it maybe in a different way, but we can put all the pieces together in these two forms. So let's go through long division, and I think you guys have done this in the past. I'm pretty sure you did this in advanced algebra, but we're going to go through and do this the same way. The work's going to be a little bit more involved, but I'm still going to ask kind of myself the same question. How many times does that divisor go into the original, or at least part of the original? So let me write a few things down here, and we'll get started. Okay, so I wrote a bunch of stuff down. Right away it's going to look more complicated than the first example. What I want you to notice is I still have this original, but when I write the original it looks different than the original right there, and I have to account for every power. So even though x squared and x weren't in the original, I still want to write them down in my solution. And then over on this side I'm still going to write down that divisor, divided by x squared plus x plus 1. So it's going to be kind of the same process, but I am going to ask a different question than before. So this time I'm going to look at my first term in the divisor, x squared. I'm going to say, what do I need to multiply that by to get the first term here? So what do I need to multiply that by to get 2x to the fourth? And the answer would be 2x squared. And that's what I'm going to write down in my answer part. And because it had an x squared in there, I'm going to write it right above the x squared part there. So that's what I started with. Now in our basic division question, at that point we took what we had here and we multiplied it by this entire idea and wrote it down here. So I need to do 2x squared times all of this and write this stuff down right there. So 2x squared times x squared is 2x to the fourth. 2x squared times an x is 2x to the third. And 2x squared times a 1 is 2x squared. Okay, so take what I wrote in the top line in the answer part, multiply it by the divisor to come up with my new answer. And then just like before, I'm going to subtract that entire thing from the row above. So I like to put parentheses around it. It reminds me that I need to subtract every single term. Okay, and when I do that, I should always get 0 for the first part, 2x to the fourth minus 2x to the fourth, that goes away. X cubed minus 2x cubed is a negative x cubed. And then 0x squared minus 2x squared is negative 2x squared. This is going to be probably the trickiest part because you're going to forget about that negative symbol too many times. Okay, at this point in our original division problem, we would have dropped down the 0x. So we're going to do the same thing here, even though it really means 0, it's still important in the process. Then I go through and I ask myself the same question again. What do I need to multiply the first term of this to get the first term here? So I need to multiply x squared by a negative x to get negative x cubed. So that's what I'm going to write up right here, negative x. I take that part, what I just wrote up here, negative x, and I multiply that by every single thing in the divisor. So negative x times x squared is negative x cubed. Negative x times an x is negative x squared. And negative x times 1 is negative x. Again, all of this row is going to be subtracted from the row above. Be really careful with your signs here. Negative x cubed minus a negative x cubed, really plus x cubed, is 0. Negative 2x squared minus a negative x squared. So think about that. Negative 2x squared, and in the end it's really going to be plus x squared. Gets me a negative x squared. And then 0x minus a negative x, really plus an x for that part. Okay, so just kind of go through, check that, make sure that what I'm doing, you're following the different steps here. And at this point, we would take this negative 3, drop it down to right there. And I go through and I ask myself the same question again. What do I need? What do I multiply this first term by to get this? To get the first term of my line at the bottom. And so x squared times a negative 1 would get me negative x squared. So I write that up right there. Now notice, I don't know if I've been mentioning this, but I try to keep whatever I'm writing up here, I put in the same row as that power. So that I had a 2x squared, I put it in the x squared row. I had an x, I put it in the x row. I had a number, it goes in the number. So that's another way just to stay organized. But again, I take what I have right there, that last thing I wrote in the answer, and I'm going to multiply it by everything in the divisor. So negative 1 times x squared is negative x squared. Negative 1 times an x is a negative x. And negative 1 times a 1 is negative 1. Again, all of that is going to be subtracted. Minus symbol there. And we just got to be careful with the signs again, but I would get 0 for the first part. X minus a negative x, so really x plus an x is 2x. And negative 3 minus a negative 1, really negative 3. Plus 1 gets me negative 2. And just like before, we want to try and rewrite, or at least label all the different pieces here. So we'll just kind of quickly go through and do that. This entire row here was the original. Over here, this was the divisor. This was the quotient. And that must mean that this right here is the remainder. So same as the first grade example, now we're just doing the pre-calculus example. And so when I ask you then in the last part of those instructions to combine them to make a formula that kind of put all these 4 pieces together, I can basically follow that first grade example to piece them together. So think about that for a second. As I start writing some things down, does that idea make sense? The first thing we wrote down for the first grade example, we took the original and just divided it by the divisor. So we said, I'll kind of put this, separate this a little bit. We said that 2x to the fourth plus x cubed minus 3, so that was the original, divided by x squared plus x plus 1. Okay, so we took the original and divided by the divisor, and that should get us, it's going to equal, okay, the quotient, which was 2x squared minus x minus 1, plus, and then we still have this remainder left over. That remainder of 2x squared minus 2 still needs to be divided by the divisor. It hasn't been affected by that yet. So we have the quotient, the answer, the remainder that still needs to be divided by the quotient. So x squared plus x plus 1. Okay, so that was the fraction form of this. This is going to be important later on because in section 6 we talk about rational functions. This is a rational functions, and now to a certain degree we've simplified it, even though it doesn't look very simple right now. And then the other way we wrote it was in the what we're going to call polynomial form, and that was basically saying that the original, so let me split this up here a little bit more for you, okay? Got too much black going on here. Okay, so this was the fraction form right here. Polynomial form would look something like saying we took the original 2x to the fourth plus x cubed minus 3, and that is going to equal, I don't know if I can fit all this in here, but we're going to try. It's going to equal the divisor, which was x squared plus x plus 1. So that was kind of like the 9 in our first grade question, times the quotient, which was 2x squared minus x minus 1. So that was like the 17 in our first grade question. And then we still need to add the remainder, which was 2x minus 2. And that was like the 3 in our first grade example. So just kind of see how the pieces fit together there. I realize that it would be hard to take the time to actually go through and simplify this again and try to get the original, but if it follows in the first grade example, hopefully it will follow in this example too. And one last thing, this was the polynomial form, just to kind of remember that. Okay, I've talked long enough. I better stop. We will see you in class.